Hi everybody. I just wanted to talk about how to calculate p-values using technology because I've had a lot of people ask me about them. So again, just to remind everybody that again, I don't require a graphing calculator or you to use a computer on the exams and stuff. So on the final exam, you shouldn't have to calculate the p-value directly. You can either use the classical approach or just approximate the p-value using the value in the table. So I just wanted to talk about this a little bit. So here's a problem where you've got a football game here, and if the point spreads are accurate, right, you would expect about half the games to result in the team favored not to beat the spread. So basically, the null hypothesis is that the probability is equal to 0.5, and the alternative hypothesis is that the probability is not equal to 0.5, so this would be your p sub 0. And then there's 45 randomly selected games, and you have a 0 if the team did not beat the spread and a 1 if the team did beat the spread. And again, you can open this again by clicking on this icon. But if you count the number of ones here, there's 21, so that means 21 teams beat the spread, or 21 games the teams beat the spread. So basically what you want to do to calculate your p hat, the p with a little arrow over it, is to take 21, the number of ones, divided by 45, and that should give you about 0.4667, something if you round it. I think it's like actually 0.4666 repeating, but you'll have to round that at some point. And so if you plug that into the formula for calculating the z-score, which if you remember is p hat minus p sub 0 over the square root of p sub 0 times 1 minus p sub 0 over n, then what you'll get in that case is you should get, and again the formula is on the bottom of page 487 in your textbook if you're looking for it. So you'll basically have 0.4667 minus 0.5 on top over the square root of 0.5 times 1 minus 0.5 over 45, and that should give you a value of about negative 0.4472 roughly. So if you round that up to 2 decimal places, that'll give you negative 0.45. So if you do decide to use a table for this one, if you look at negative 0.45 in table 5, you should see that that corresponds to a probability or an area under the curve of about 0.33. Now remember, this is a two-tailed test, so you'll need to double the area, right, because you've got a not equals to sign in there. So if you double 0.33, that gives you about 0.66, which is pretty close to the answer, but again, you know, the tables are only good to 2 decimal places, and remember that the actual answer was, again, closer to negative 0.4472, not rounded to 0.45. So if you use StatCrunch, you will get a slightly different answer, and again, that is the answer that they want you to have in this case. So if you do go to StatCrunch, just to tell you how to do this, so I did already have this open here, so again, maybe just to remind you how to get to here, you just go to Stat, and then Calculators, and then go to Normal Distribution. And then what you want to do here is, you know, this is the probability that, I guess they have an x here, but you can think of this as the z-score. The probability that the z-score is less than the value that we got, right, which was negative 0.447. You don't need to change the mean or the standard deviation. And then go ahead and compute that. So that gives you this area, which is about negative 0.327365553. And again, this area needs to be doubled, so you can imagine there's another red area over here. And again, since the normal curve is symmetric, you can just either add that number to itself or just double it. And so if I do double that number, just to go into a calculator here, I'm just going to copy this number into the calculator. Let me just swipe over this here. Oop. Sorry, let me try that again. So it was negative 0.4472. Right, that gives you this area. So if I just swipe over that value, I'm just going to paste this into my calculator. and then just go ahead and double that, so either add it to itself or multiply by 2, you get 0.64 or 0.6547, which if you do round that, does give you the answer of about 0.655. So again, if I do have you do something like that, you can just use the table to get an approximate value, which would be 0.66. I'm not going to require that you use StatCrunch, but just be aware that StatCrunch or computers will, in some cases give you a more accurate answer, especially since you have to round things to 2 places. So just something to be aware of. So all right, well, I hope that makes sense. If you guys have any questions or anything about that, just let me know. All right.